In this episode of FUM0145 machining, we are going to drill a hole into that quill holder. And the first thing is to tram this, align this so that we are going to get the hole straight. One could probably do this in the lathe itself, the hole, but I don't trust my tailstock. It's really flimsy, so setting up the line boring on that one is quite impossible in an accurate way. And I trust this old lady more than that new guy, and therefore I think I can get more accurate result actually using this one, measuring it really accurately here on the lathe, and then setting up this accurate way. So the first thing is to tram it. I already did this. It's a tedious process, but I can show you how I measured it. So the first, let me switch this camera on and put it recording, and then switch on the mill. Now when you do this, you should actually, this rod here is very accurate. Actually it's quite straight, but this one, the collet, it has, there is a whiplash in that one. Not a lot, but there is. So in order to get the most accurate results, you should roll it a little bit. Just the tiniest amount. Slowly. Roll it. So then you can see that you can see in the picture, I put a picture somewhere, maybe there on the corner, so that you can see the dial indicator. It's now wiggling a little bit, and now when I go a little bit farther away, it starts to wiggle more, but it is centered in the zero, and that's important, so that it is wiggling around the zero, equal amount either way. So this way you can mitigate the problem of whiplash. And now I know that this rod is now on average straight. So, and the next thing to measure in this case is to measure, let me switch this off. So the next case is to measure the underside of this thing. And this magnetic base is really uncomfortable. And now let's put it somewhere. And now you are okay. I'll switch on this one. There you are. Now I'm looking for the maximum point where it's precisely under the, and I believe there you are. Okay, let's zero that one there. There you are. And now I'm measuring this kind of tilt, and this also should be straight. I'm not sure whether it is. It should be, but let's see how it is. Okay, now you can see that it's not around the zero. Let's put it around the zero. There you are. Yeah, okay. And now when I move it back, it should. And now you can see it's not actually straight. It's nothing but. Yeah. So this must be adjusted. So I need to tilt it a little bit. Okay. This is tight. Oh yeah, okay. So, and this is, yeah, it is, well, yeah, okay, let's do this. Let's take that much. Okay. Well, now we are talking. Oh, yeah. It's there. Now it is there. Let's see what happens when I lock this. Okay, it didn't change too much. Oh, did it? Not too much. Good. Let's recheck this one. There. Okay. Well, it might be just a hair. No, it's actually there was a deviation at one point, but yeah. Now it's inside, I would say, 200ths of a millimeter. It's very hard to get it more accurate than that. Now, next thing is to measure the thing in the lathe. Well, this very flimsy dial indicator setup is just to measure how much do we have difference between the points when I move this like, oh, it's locked. When I move it like this. And what I'm getting here is nothing. Really, nothing. And yeah, I can see when I wiggle it, the dial indicator is touching. And there is actually nothing. Okay, so I can trust this surface to be parallel with the vase. Very nice to know. Okay, that was one. Oh, and this was one of the flimsiest dial indicator setups I have seen in a long time. Well, last time when I measured the height, I used, I made a fresh center here and used that. That's a very coarse method of doing this. But on the other hand, I didn't need the accuracy for this one, but now I need it. So now another method of doing this is this pin here in between is dialed in as accurately. It's in the center. I have dialed it in as accurately as I can. I have I did quite a long time for it so that it really is accurate. And furthermore, now I know the diameter of this pin. It's 8 millimeters. Okay, that's good to know. And I will be using the top surface here as my reference in this case. And depth mic is a very good tool here. So just measure it from there, like that. I already did this, but I show you how I did it. So, and I did this multiple times. So here you go. And reading the depth mic is not easy. This is actually 24.11. millimeters. Oh, sorry, 34, because there is an extension here. There is this mic. This is an extension of 25 millimeters. You put an extension on here. Normally this cannot measure that kind of distance, but now it can. And then I measured it, and the distance from the top of the pin is 34.11 millimeters. And because it's 8 millimeters, you just subtract 4 millimeters out of it. Okay. When I did my sanity check, however, with this one, I tried to measure it like this, the normal way, and I found out a lot of deviation in my measurements. Now it's like 36 millimeters. This is not a really reliable way of measuring this. There is another way of doing this. It's there is this thing you can use, and then that one. They are level, and when you measure it, you just place this here under. And yes, this is not straight, this pin. There is a taper out, so well, I need to bypass that one, so therefore it's not straight, but it still gives more accurate result. I can now be confident that my measurement of 13.11 millimeter from this surface to the center is correct. Okay, that's about measuring. Now we know, and of course we are placing it in the exact center. And since this face had no deviation, we can align it straight into the milling machine. Okay, now we have this dialed in, it's straight, and well, next thing is to align the Z-axis height and also the Y-axis, so that we are boring the correct place. Well, and for this thing I'm using a mechanical edge detector. I will show you a better view of this. Let's see if I can set this up correctly. Oh yeah, this will be nice. Okay, let's put it on. And then we need to rotate that one. We need some speed here. First, let's see. That's more than enough. Let's stop it first. Oh. Now. Well, it's making a sound. How this operates is that when you go closer like that, I know that the Z is half of the diameter of this thing above the surface, and the diameter of this little thing here is 6 millimeters, so it will be 3 millimeters above the surface. So it's two turns from here. 1, 2. Now it's exactly on the surface. And the next thing we will do is to dial in. It should be 13.11 millimeters. Ah, damn. Okay, I will now take this off. You have seen how it works. One thing about these mechanical edge detectors is that you should there are some well, lucky me, I have reserve batteries. 2 of them, the other one that just failed is now loading. Okay, so when you are choosing a mechanical edge detector like this one, well, there are some cheap ones, but in this case, this tool is a precision tool. This means that the surface finish, for example, must be, well, it must be very good finished. Otherwise, this really don't work, and this just cannot be done very cheaply. So there aren't any brands, not many brands I trust on these, and well, in this case this is a Starret, and well, yeah. Okay, next thing is to dial the Z correctly. It was 30.11, so 20 turns and then some change. 20 turns, okay, counting in Finnish. Oh, 20. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and then 11. It's there. Yeah. And then lock the Z. 3 millimeters from that surface, and now we have to move it. Okay. So I have a dial here which is in millimeter accuracy, and then I use this for more accurate things. Okay. So now we need to move. 39.79. 39. Really? Okay. 39. So 1, 2, 3. It's almost there. Okay. 10, 20, 30, 9. Yeah, that's 9. And 79. 20, 40, 60, 70, 9. There you are. That should be in the middle. And it looks like it is in the middle. So now we have dialed this in. This is locked, that is locked. I should not touch this in. I try to keep my hands off from this. Okay. Next thing I will put a drill there. This will be fun. been a simple drilling job became a rescue mission. These things happen sometimes for me, and this is something, yeah. Okay, I got drilled through the 14.5 millimeter hole, no trouble in drilling, but the hole is in wrong place. It's 8 millimeters too high. It didn't destroy this workpiece, but it made things a lot more difficult. I'm on the road at the moment. My intention was to use another drill, 29 millimeters, and then just drill through. Well, I'm still intending to do that, but as you know, there is a big hole on the side, and that doesn't work well with drill, not at all. But in this case, I can do that with. I first bore 29 millimeter hole about 5 centimeters long into there, and then it leaves just a little bit of that thing, the misplaced hole, and then I drill 29 millimeters. That should do it. We shall see what happens. Well, and the reason why it is 8 millimeter stop, let's see if I have footage here. I think I said it as well. And because it's 8 millimeters, you just subtract 4 millimeters out of it. And those of you who have been listening carefully said, oh no, he's going to drill the hole in the wrong place. Yeah, because now when I measured this thing in the lathe, there was this 8 millimeter pin. And I measured that, okay, the top of this pin is away from the top of this surface, something like 30 millimeters. Okay, and then I said, it was 34 millimeters. And then I said, okay, you just subtract the half of the diameter of this pin. No, you should add half of the diameter. Yeah, that's a very typical mistake for me. Instead of adding, I subtract. Instead of subtracting, I add. Well, instead of everything seems to go upside down every now and then. But that's maybe I have some logic circuit here. It should be an and it is an and. Yeah, okay. Let's do this boring job. is now doing better than I expected, actually. It would have been the best solution to make it correct right from the start, but this one works also. Of course the pilot hole should be in the middle of the hole, but in this case it ain't. And it might want to twist the drill while it's drilling, but so far I haven't noticed a lot of that kind of flex. So, I'm also drilling quite slowly. But anyway, it's doing well, and furthermore, the final diameter is 35 millimeters. This is 29. So it could go quite a bit into sides, and despite I could, nevertheless I could get a good result after all. But, mistake anyway. But I'm glad I did it this way. I didn't try any other method. This was probably the best. And why I'm drilling it? What's the reason for that? Yeah, the reason is that I can only go so far from one side. I'm going to bore this to the near size. And I have to turn the workpiece around and drill from the other direction back, because otherwise I would have too long stick out in my boring bar. Lots of chatter, etc. Don't want that. And furthermore, I don't have that long boring bars. So, drill. This is not the deepest hole in the world, but it is quite long. Okay. These old guys really do their job, and we have a lot of chips there, and I need to take care of these. This is really amazing how much you get this stuff, and the rest will be vacuumed. Now we have a 29 millimeter hole. Next I will set up the boring bar, my Wallhaupter, and well, it will become something like 34.9 millimeters. And the 0.1 millimeters I will do with a hand reamer. This here is now the boring bar setup. And this is horribly tight. Okay, I have made a boring tool, this insert here. This is carbide. I ground it from an parting tool carbide which I had. I have diverse carbide inserts and just to have some carbide. And this one was suitably sized. It fits like anything. I just needed to grind the suitable relief angles, etc. And well, it's very good. Well, the surface finish is typical hot rolled steel, but there is nothing you can do for that. And this works really nice. You just take some time to go into there, but I can take half millimeter at a time, and that's very good. There you go. I have a proper hole at this side, but since this boring bar doesn't reach all the way through, I need to turn the thing around and align it such that well, that the holes meet and the accuracy should be best possible I can achieve. So the first thing is to remove this boring bar, not so I don't stumble into that one when I do the things. So that's taken from the way, and then this baby. This is maybe I should clean a little bit before I start zip evacuation for the other side. I just put hose into that hole and there you go. Okay, let's see now. My construction site. And we are good to go, I believe. I can see very soon whether this is on correct place or not. Well, it is. Chances that I have made the same stupid mistake this time, well, I'm notorious of making those, but well, we shall see. So now I just put back the, there you are, and then I take away this, we don't need any more. And then the speed, what it was originally, it was around 150 revolutions per minute. like that. That's good. Oh yeah. Now let's go and touch. Oh, this is... Oh, better to do this in neutral gear. Okay. Easier to rotate it when it's on neutral. So we need to take back the blade. Okay, now we are touching. So we should be good to go. Actually, I set this automatic stop when it's past there, and then we can use, now this is nice. I can put it into this hole, like that. Now can you see that? You cannot see that. I can show it to you. It's like that. Now I just switch the vacuum on and it will take the chips there. Okay, and now let's see. This is exciting. It's always when you start with the boring bar. The first pass is really like yeah. Okay. I'm just fishing any high spots inside there, so that's the reason why I'm taking so little. Yeah, chips went away. Oh. I think this is now really good. This is quite tight fit, exactly as it should be. There is some slop. If you could tell, I will show you. I have a dial indicator which is now measuring how much does it. If I now can get this on like that. So let's see. Switch it on. So actually this shaft is not round. There is. If I pull it here, this is the best position. I can get a little bit over 200ths of a millimeter. But if I rotate it a little bit, so then I start getting 400ths of a millimeter. Nice. Okay, there is quite tight spot. Yeah. So. Well, it's not round, so hopefully it doesn't matter. It's not too much of a not round, and it's not supposed to rotate. You only do this kind of thing with that. So, in the next episode of FUM0145 Machining, we are going to do something for this Quill. Well, first of all, we have a gear rack which should be attached to it. Then it should have a Morse 2 taper in one end, and that's pretty much of it. Yeah. Oh yeah, I will make here for the Morse 2, I make a provision for tang, and I also make it so that those things that cannot be extracted without a tang, you can do that. There will be a slot in this, and well, let's see how it goes. And yeah, so, but that will be in the next episode of FUM0145 Machining. Till then, bye!